Today I'm gonna teach you exercise 4.2, question number 15. 2x plus 2 raised to power minus x plus 6 minus 20 equal to 0. In algebra, if we have base same with different powers, if we have same base with different power, what we will do? We will write base one time when we will add power. Similarly, 2 raised to power minus x plus 6. It means 2 multiply 2. It means one time we will put minus x and next time we'll put 6. But it gives when two terms are multiplied with different base. Same base with different powers. What we will do? We will write base one time, we will add powers. So this term we can write in the form of this term, and instead of multiply we will use dot. So here we write 2 raised to power x plus 2 raised to power minus x dot 2 raised to power 6 minus 20 equal to 0. And why we will break? Because we want this term and this term same. When these two terms become same, we will consider. So our equation becomes easier. Now 2x plus 2 raised to power minus x, and answer of 2 raised to power 6 is 2 into 2 into 2 into 2 into 2. 1, 2, 3, 4, 5, 6. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64. 64 minus, this is not a point, this is dot product, equal to 0. Now we can write x plus 64 2 raised to power minus x minus 20 equal to 0. Now we can write 2 raised to power x plus 64 2 raised to power x minus 1. For example, if we have a square, so we can write a raised to power square. This in the form of, if we have 4, then we can write a square whole square. If we had 6, we can write a 3 cube into 2, because 3 into 2 6, 3 2s are 6. Now if we have minus 6, what we will do? We can write 6 into minus 1. Similarly, we can write 2 raised to power x and minus 1 outside. And if we multiply, what we will get? 2 raised to power minus x minus 20 equal to 0. Now this term and this term is same, so we will consider. Let 2 raised to power x is equal to y. So equation become equal y plus 64 y minus 1, 64 y raised to power minus 1 minus 20 equal to 0. Now y plus 64 y raised to power minus 1, we will write in the denominator positive 1, negative 1. When we write in the denominator, negative 1 becomes positive 1. So minus 20 equals to 0. Now y, by taking LCM, we will multiply with whole equation. Y is multiplied by this term, y is multiplied by this term, and y is multiplied by this term, y is multiplied by this term, because LCM is y. So whole equation multiplied by LCM. Y cancel, y square plus 64 minus 20y is equal to 0 into y 0. Y square minus 20y plus 64 equal to 0. 64 1 and 64 multiply. 64 will make pair. 2 3s are 2 2s are 4 1s are 4 6 are 24 4 5 6 7 8 8 8 are 64. Now 64 minus 63 30 12. If you add but it gives 20, so it means the factor becomes minus 16y minus 4y, because there is minus minus plus 16 plus 4 20, sign minus. And if you multiply, what we will get? Plus 64 y square. C4 equal to 0. Now in making pair, we will take common from these two terms. Y, what is left? 1y is left, minus 16 is left because y is common. So now we'll take minus 4 as common because here simple constant with the negative sign, so we'll take minus common. It gives us minus with constant, so minus 4 common. Minus minus plus 4 1s are 4, minus plus minus 4 1s are 4. What is left? 2. 4 is used, 2 is left, it makes 24. 4 6 are 24. So y minus 16 and y minus 4 equal to 0. First of all, take y minus 16 equal to 0, y minus 4 equal to 0. Minus 16 will take in the right side, minus 16 become positive 16, y is equal to minus 4 become positive 4. Now here we can see that we consider 2x is equal to y, so we put y is equal to 2 raised to power x. Here we put y is equal to 2 raised to power x is equal to 16, and again we put 2 raised to power x is equal to 4. By making base same, how to make base same? 16. 2 2s are 4, 4 2s are 8, 8 2s are 16. 1 2 3 4 2 raised to power 4. 1 plus 1 plus 1 plus 1, 2 raised to power 4. It means how does 16 comes? 2 raised to power 4. If the base is same with equality sign, 2 is equal to 2. If the base is same, it means powers are also same. So x is equal to 4. Now 2 raised to power x is equal to, how does 4 comes? 2 raised to power 2. Now both base are equal, it means powers are also equal. X is equal to 2. So our solution set becomes 4 and 2, which is our required solution.